Okay, this is project test 4, video number 1, and it's covering questions 1 to 10. So which of the following statistics is defined as the 50th percentile? Well, the mean is purely the average. We added them all up and divided by the sample size. The median is where we line them up from least to greatest, and the middlemost value, or the 50th percentile, all right, is the median. Now, please remember, if you have an even number, you're going to take the even number plus 1 and divide it by 2. All right, so basically the two middle, if you have an even number of values, you're going to have to divide them by, sum them, and take the average of the middle 2. So even number of values, sum the middlemost, sum the middle 2, and divide by 2. If you have an odd number of values, it's not a problem. Consider this. If we had the numbers 1, 2, 3, 4, and 5, the median would be 3. However, if we had 1, 2, 3, 4, 5, the median would be 3 plus 4 divided by 2. So 7 divided by 2, and our median would be 3.5. All right, so it depends on whether we have an even number or odd number. The mean is just the average of all values, average of all. Mode is most common, and there can be multiple modes. All right, the interquartile range is Q3 minus Q1. And the standard deviation is the average distance from the mean. Average distance from the mean. All right. But the answer to number 1 is A. Number 2, a researcher wanted to estimate the average amount of money spent on extracurricular activities per school in a certain region. The researcher randomly selected 20 public schools and 20 private schools to use for the sample. Which of the following best describes the type of sample that was taken? Anytime you take groups, as soon as you have groups, it's either going to be a cluster or it's going to be stratified every single time. So it's either going to be cluster or stratified, so that gets rid of census, convenience, and simple random. Now, a cluster, each cluster needs to look alike, and a stratified, they're going to be divided on the common characteristics. Well, public schools probably does not look like a private school, so that gets rid of cluster because they're stratified based on, we have one strata, which is public schools, and another strata, which is private school. Strata public, strata private, they're divided based on a common characteristic, which is the type of school that they are. All right, number 3. Students in a large psychology class measure the time in seconds it took each of them to perform a certain task. The times were later converted to minutes. If a student had a standardized score of Z equals 1.72 before the conversion, what was the standardized score after the conversion? So basically, the times were converted to minutes, and originally it was in 60 seconds. And so basically we're dividing by 60. However, here's what changes. Measures the center. Change. Measures of spread. Measures of center would be your mean and your median. They're going to change by the multiple, which in this case is 1/60. Measures of spread. That would be IQR, range, standard deviation. They also change by the multiple, which in this case is 1/60. Variance changes by the constant squared, so 1/60 squared. But the z-score, because of its a ratio, does not change when you add constants or multiply. So multiplying by a constant or adding a constant will not change the z-score. The z-score remains at 1.72. Number 4, a researcher conducting a telephone survey is concerned about possible sources of bias. Of the following, which is the best example of non-response bias? All right. The wording of the question is leading of the survey leads people to respond in a certain way. Wording of the question, poorly worded question, is a case of response bias. So this is response bias, and we're looking for non-response. So that's wrong. The behavior of the interviewer leads people to respond in a certain way. This is also response bias. Maybe I was aggressive on some questions, etc. People might be uncomfortable with the survey question, and as a result, might not always respond to the questions truthfully. Again, this is a third opportunity for response bias. And we're looking for non-response bias. Many of the people selected to participate in the survey who do not respond might have opinions different from those who do respond. Non-response bias is when a group does not respond to the survey, but they were selected in the survey. You selected them, but they chose not to respond. This is an example of non-response bias. Letter E, people without telephones are overlooked in the sampling procedure. So if we do not account for a part of the population, in this case, we overlook them, this is going to be under coverage. This is an example of under coverage bias. Now, what we wanted was non-response bias, which is where we actually had them grouped together in a poll, but they chose not to respond for some reason or other. Response bias, we worded the question poorly, we were aggressive in the way we asked it, or we were leading, or it was a sensitive question and they chose to lie as opposed to answer truthfully. Just a moment. Okay, number 5. At a large conference of teachers from a variety of subjects, we have a group of different subjects, a random sample of 50 math teachers attending the conference was selected. All right, so we randomly selected some math teachers. Among the selected math teachers, 28% had taken one or more courses in statistics. For which of the following populations is 28% a reasonable estimate of the percentage of those who have taken one or more courses in statistics? So basically, we have a p-hat of 0.28. All right, and we took a sample of size 50, and there are 50 math teachers. All right, so this is a random sample of 50, n equals 50. So can we apply this to all math teachers? And the answer is no, because the conference probably is not, those math teachers who attend the conference are not representative of all math teachers. All right, all math teachers who attended the conference. Well, that's definitely a possibility. Let's see if there's anything else. All math teachers who've taken one or more courses in statistics. Once again, we don't know that those who attended the conference are representative of all math teachers. All teachers who attended the conference, and we know that's not true because we didn't select from all teachers. We only selected from the math teachers. And obviously it's not all teachers, so our best case is B. So our sample came from the population of math teachers who attended the conference. So this is the population, and from that population, we took a sample of size 50. Number 6, the prices in thousands of dollars of the 35 used cars at a certain car dealership are shown in the table below. Which of the following best describes the shape of the distribution? Well, if I'm looking at this distribution, and I have this number line, and it's 7, 8, all the way up to 16, I notice I have one value here, one value here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It's like, oh, looks to me like it's been stretched, it's been pulled to the right. So if it's stretched to the right, then it is skewed to the right. Sometimes it's referred to as positively skewed because we stretched it in a positive direction. Okay, number 7. Data were collected on the number of text messages sent by each student in a large high school for one day. A box plot of the data is shown below. Well, I'd like to remind you that from this right here represents Q1, and right here is 25% of the data. This is also 25% of the data. This is 25% of the data. And this is 25% of the data. And this is my median. And this is Q3. Now, because we have no outliers, this is my max, and this is my min. So, based on the box plot, which of the following statements is the most reasonable conclusion? All right, so we're looking for most reasonable conclusion. There are more students with data values between the median, values, excuse me, there are more data values below the median than there are data values above the median. No, 50% is below the median and 50% above the median. That's false. All right, hopefully that's not a struggle. Continuing on. There are more students with data values between the first quartile and the median. So right here is with 25%. Then there are data values above, then there are students with data values between the median and third quartile. No, both have 25%. Each section is a quartile. There are fewer data values between the first quartile and the median than there are students with data values between the median and third. Once again, we have 25% here and 25% there, so that's false. There are approximately the same number of students with data values between the first quartile and the minimum, so basically 25%, as there are students with data values between the third quartile and the maximum, which is also 25%. So this is definitely a possibility. All right, let's make sure that D is not a better choice, or letter E. So the data are less spread out between the first quartile and the median. Well, I'm looking at this distance, and this distance is much larger than this one. So this is false. So my best answer is D. All right, the data is definitely more spread out between the first quartile and the median than it is between the median and the max. However, both cases have 50% of the data. It's more spread out on the lower end. All right, on number 8. One day before an election in a large city, each person in a random sample of 1,000 likely voters is asked which candidate he or she plans to vote for. In the sample, 55% said that they will vote for candidate Taylor. A margin of error is plus or minus 3%. So we have basically 0.55 plus or minus 0.03, which means our confidence interval is somewhere between 52 to 0.58. And so we believe based on our confidence interval that candidate Taylor will receive between 52 and 58% of the vote. So A, the proportion of all likely voters who plan to vote for candidate Taylor must be the same as the proportion of voters. No. It'd be nice if it were, but our samples rarely ever are exactly the same as the population. The sample proportion minus the margin of error is greater than 0.5. That's true, which provides evidence that more than half of all likely voters plan to vote for candidate Taylor. That sounds pretty good. It does appear that way. It is not possible to draw any conclusion. No, it appears it is because 50% is not contained in the interval. It is not possible to draw any conclusion. No, because 50% is contained in the interval. And once again, it's not possible. So our best answer to that is B. Based on our confidence interval, whatever that level is, if it's 95%, we're 95% confident that candidate Taylor is going to get at least 52% of the vote and maybe as high as 58%. All right, number 9. The caffeine content of an 8-ounce can of a certain Coke is normally distributed with a mean of 33 grams. A randomly selected 8-ounce can containing 35 grams, so we have an X equal to 35, is 1.2 standard deviations above the mean. This time they gave me a Z-score. They gave me a Z equal to 1.2. Approximately what percent of 8-ounce cans of the cola have a caffeine content greater than 35 milligrams? So we want the probability that X is greater than 35. So let's make a little diagram of this. I think it'll help out immensely. In my diagram, I have a mean of 33, and we got a random sample of 35. And we're looking for this percent. We want that area. Now, one thing we know is if we converted this into a Z-score, this Z would be 0, and this would be 1.2. And we know they gave us that value. So from that, I can do a norm CDF. So let's do that real quickly. Second vars, norm CDF, lower bound 1.2, upper bound, we're going to positive infinity. So we're going to load the calculator up with a bunch of 9s. And since we're working with Z-scores, our mean is 0 and our standard deviation is 1. And I end up getting 0.1150 as my probability or my area. So 0.1150, and my closest answer is 12%. So 12% is our answer. Number 10, a random variable has a mean of 120. So X has a mean mu equal to 120 and a standard deviation of 15, where Y has a mean of 100 and a standard deviation equal to 9. If X and Y are independent, approximately what is the standard deviation of X minus Y? So for the means, I can just go 120 minus 100, and I end up getting the mean of X minus Y equals to 20. And it's fine if that's been a negative number. But with standard deviations, I can't add them directly. I can't subtract them at all. I have to add them. But I first must convert them to a variance. So I'm going to square them. And even though they asked me to subtract them, I can't. I have to do this. So I convert it to a variance, and then I take the square root of that. So 15 squared plus 9 squared equals, and I'm just going to take the square root of that, raise it to the half power to do so, and I end up getting 7.49, so my best answer is number 10, which is 17.5. All right, thank you.